Hello, everyone, and welcome to this second session of this webinar, where you will get a better understanding about how you can keep your substation secure by migrating and or retrofitting your protection relays. This webinar has been conceived for energy automation and protection professionals. Whether you work as a protection engineer, project manager, in operation and maintenance, as well as whether you have cybersecurity responsibilities. We have divided this webinar in two parts. The first one is related to giving you a context on how technology have evolved. And the second part is more specific on the concepts and how to perform a retrofit in case that you have a legacy device. My name is Luis Francisco, Sales and Business Development Manager at Siemens. And today I will be moderating and also presenting during this event. And with me, I have the pleasure to have on stage Hans-Dieter Boye. Dieter graduated 4 years ago from the Georg Simon Ohm University, from the Ohm's Law, you remember that? Here in Nuremberg, Germany, and as a communication engineer. Dieter is a high-caliber professional with deep knowledge of the art of protection relaying. Today, Dieter works supporting customers and partners worldwide, smartly transitioning their installed base as a service lifecycle manager. Also with us, we have Dr. François Simon. François graduated from the University of Haute-Alsace in France as electric and electronic engineer in 1993. François is a seasoned and experienced professional who, in the context of protection and control system, has been adding value to customers and consulting and promoting communication and security systems, for SIPROTEC and SICAM product families. So François will be joining us during the Q&A session. And talking about Q&A session, please notice that since you cannot ask direct questions to us as we are presenting, we invite you to type your question in the question box or also in the chat. And we then gladly will answer them afterwards in the Q&A session. So that said, keeping your critical infrastructure secure is more important than ever. Energy grids have evolved in complexity as well as the creativity of those who want to interfere with the normal operation of electrical substations. And here, in that context, please allow me to have a short recap of a previous webinar related to managing vulnerabilities and security patching. So here we have this graph, and the first question that I would like to ask you is, do you have active security patch support for the devices that you have deployed in your OT? Well, if the answer is yes and you have it, this is great. You have the awareness measures in place to address any cyber-related issues. Now, if that's not the case, and there are still products on your OT deployment that are already or are going to be out of support concerning security patches, what to do then? So the next question should be, can we migrate or retrofit solutions, here? If this is the first time you're joining one of our webinars from this series, I would like to encourage you also to watching the following webinars on demand. The first one that I would like to recommend is exactly that regarding the recap, is keeping your substation automation secure by migrating SICAM AK3 to SICAM A8000. The second one is about managing vulnerabilities in the energy automation systems with an introductory and hands-on session on security patching. And the third one, and this is more related to this webinar, I would like to recommend you SIPROTEC 5 Compact from selection to operation. You can find all the upcoming as well as the on-demand webinars by tapping www.siemens.com, and then you go to product and services, and then you scroll down, you will see energy, followed by clicking energy automation and smart grid, and then scrolling down once again, you go to webinars for energy automation and distribution systems, and join us in our efforts to transform the everyday together by smart transitioning your installed base. Now, technological development has been key to our development as humanity. From invention of the fire to the wheel, from airplanes to rockets, each technological development requires us to understand, utilize, and then adopt these new technologies to our everyday life. That said, I would like us to find some common ground by looking back in the development of protection relaying and substation automation systems. Now, first, protection relays. The first protection relays were electromechanical devices. Some are still in operation today. Electromechanical relays consist of coils which operate moving parts to provide detection of abnormal operating conditions, such as overcurrent, overvoltage, reverse power flow, overfrequency, underfrequency, and so on. Electromechanical relays are typically highly demanding in terms of maintenance. I still recall those ones, in my early phase in my career, where we have to plan weekly maintenance to those devices that has been there for decades. I also recall the big discussion we had when we were deciding to migrate, those electrical mechanical relays to the statics ones, solid state relays. Are we crazy? I mean, how to trust a semiconductor-based coil? Fully electrical operated switch that has no moving parts? Do you remember those discussions? Because we did have it in our team. Then came a big leap and disruptive technology, the microprocessor-based digital relay. Digital relays are computer-based systems where software-based protection algorithms are used to detecting electrical faults. They may include several protection functions in one unit, as well as providing metering, communication, and self-test functions. If you are as young as I am, I can imagine, you may recall the discussion also of having so many protection functions in one single device. How reliable is that? What happens if a single device fails? Oh, we're not protected. Well, today, the usage of multifunctional relays is a standard. And this technology has also evolved in what we call numerical, which is the product of the advances in technology from digital relays. They use high-speed processors executing appropriate algorithms. Most numerical relays have multiple setting groups, each often with tens of hundreds of settings, and with an incredible hardware and software capabilities, never seen before. Also today, we are experiencing one of those disruptions with cloud computing. And the disruption is coming to the protection relaying. It's also happening. We have the SIPROTEC digital twin. We have the cloud-based applications like the SIPROTEC dashboard, the SICAM navigator. I mean, there is a clear and visible trend in virtualization nowadays. All of this bringing new value, new way of doing things, and flexibility that's never seen before. Now, as well, this disruption has also been experienced in substation automation systems. And here, I would like to go back first to the first generation of automation. Standard cabling. You may remember those big and complex panels. I recall spending hours trying to solve a problem. It was, a short circuit with my tester, or it is an open cable. Fortunately, on that time, the electrical diagrams were updated, and everything was, as in the as-built documents. Yeah, of course, it was not. All the changes made over the years in the physical panels were not redlined on the documents. And a lot of the experienced colleagues and colleagues and friends, they were not there anymore. So it is horrible, it's time and resource consuming, unfortunately wasted. All that was hardwired, and if you remember, a lot of alarm panels that consisted of light bulbs with labels and mimics, right? You remember those. The second generation was the point-to-point connection. That goes with mid-80s, very parallel with the development of the microprocessor-based protection relays. So in this era, the protection relay system started talking to the automation system. There was the implementation of serial connection and also the serial protocols. They were partially hardwired. There were still some IOs collected, with some data collectors. And there was also available extended supervisory and control capabilities. The third generation, we're talking about now, the 2000s, is the digital station bus. Based on IEC 650, we saw that development for hardwired to less hardwired and more leverage on communication capabilities. Devices are fully modular and flexible, multi-vendor operable, and easily integrated with a SCADA system. What we have now in this industrial revolution is the digital substation, where we have, in addition to the station bus based on IC650, we have the process bus based on the same protocol, -9-2, and we have also cloud connectivity, edge computing. We have all those cloud applications, digital twin, analytics. A complete new world is unfolding on our eyes. Overall, technological developments are necessary to address our challenges. Some of them already exist, others will eventually be popping up in the future. And the protection and automation technologies have experienced disruption all over the history. We show here, like 100 years back to 100-something years. And one element that makes all these applications come together is the development of communication capabilities and networking. Now, I would like to invite here Hans-Dieter Boya. He will present details about how the OT communication capabilities and protocols have been developed over the years. And that said, Dieter, welcome to the stage, and my pleasure having you here.
Hello, Luis.
All right, here you go.
Thank you. So, good morning and good afternoon, everyone out there. It is a pleasure for me to show you the development of the protection device communication. With the introduction of numerical protection devices, you could for the first time send information by means of protocol to a recipient. In the beginning, the protective devices only had an isolated electrical V24 interface. With this one, the device could communicate direct or via an input-output device to the LSA station control system. The protocol used was the proprietary ILSA protocol. At this time, there was still a separation between protection and control. With the SIPROTEC 3 series, the devices were offered with either an isolated electrical or optical fixed installed interface. Transmission rates of up to 19.2 kHz were possible. In 1998, the first devices of the SIPROTEC 4 family were offered. The SIPROTEC 4 devices provided a system interface. This could be equipped with various communication modules. The structure of the modules depended on the used transmission protocol. In the beginning, there were modules available for serial protocols with an electrical RS-232, RS-485, or optical interface. At the end of 2003, the Ethernet module EN100 was introduced. This was the basic for being able to operate the new object-oriented IEC 61850 protocol. Siemens was one of the first pioneers who promoted the development of the IEC 61850 protocol. The modules could be ordered with either an electrical RJ45 or an optical interface. The switch function integrated in the modules ensured that the devices could be operated in a communication ring without external communication hardware. Then, in 2012, the SIPROTEC 5 device family was introduced. Under the slogan, "Designed to Communicate," the focus was placed on a high degree of flexibility. Modular SIPROTEC 5 devices can be equipped with up to 4 different communication modules. Each module can be operated with up to 2 protocols. There are serial modules and Ethernet modules, each with an electrical or optical design. In contrast to the SIPROTEC 4 modules, the serial modules can be operated with all possible serial protocols and the Ethernet modules with all possible Ethernet-based protocol. Now, let's look at protocol development. The SIPROTEC 3 devices were only offered with the 103 protocol. With the introduction of the SIPROTEC 4 family, the system interface could be equipped with various communication modules, so that further additional protocols can be implemented. with the serial ones Profibus DB, Modbus, DNP3. On the Ethernet module side, the communication range has been expanded in addition to the IEC 61850 protocol favored by Siemens, with Profinet IO, DNP IP. Additional Ethernet-based protocols were added with the SIPROTEC 5 device family, IEC 6870-5-104 and Modbus TCP. From 2019 on, Siemens presented the process bus solution based on the IEC 61850-9-2 protocol. The EDH-DB2FO modules was introduced to meet the additional requirement. With the serial connections, the modules could be connected to the control center device as a StarPoint or via RS485 line. Redundancy was not possible. With the introduction of the Ethernet modules, the communication devices could be operated in preferable flexible Ethernet rings. These Ethernet rings offer the possibility of continuing to communicate with the participants if the ring is interrupted by support of appropriate redundancy protocols. The redundancy protocols regulate the communication within the ring in the event of a communication failure of a participant. RSDB spanning tree protocol is one of the best known and has been tested in 100,000 of device installations. The switchover time increases as the number of participants increases. Therefore, following seamless switching protocol was introduced. HSR, high-speed redundancy, preferred by Siemens. PRP, redundancy protocols with the disadvantage that additional external switches are necessary. With the introduction of Ethernet-based communication, other services can also be used in parallel with the transmission protocols. With the SIPROTEC 4 family, these are essentially DIXI4 connection, SNTP time synchronization, and SNMP. Additional services are offered with the SIPROTEC 5 family. Connection to DIXI5, Web UI to use device online function without DIXI5, time synchronization according to IEEE 1588, synchronization accurate to a microsecond is required by the process bus function. Security-relevant log files can be sent to a syslog server for further evaluation and monitoring. Connection to a Radius or LDAP server for the secure operation with role-based access control. And this is what I wanted to present. Keep in mind that the OT development has been disrupting protection and automation system for decades. My final takeaways for you. The increased communication performance has led to hardware optimizations. There is a clear transition from serial communication to Ethernet communication still ongoing. And consequently, the OT development integrate a wide range of safety-related functions embedded in our new platform that for sure will be continuing in development. Now, I would like to ask Luis to join me again on stage.
Yep. Thank you, Dieter. Thank you for the overview of the OT development and the takeaways from your presentation. I really like how you structure the slides, and in addition, I noticed how the reliability and the flexibility of such redundancy in the energy automation system have developed dramatically. You mentioned the RSDP, the PRP, and HSR. Those are very reliable configurations. It is also clear to me that the latest developments allow the possibility to adapt products and systems to future requirements. Considering the fast-changing scenarios that we have today on the ongoing energy transition, this is something that everybody, I would say, is looking for. Now, talking about benefits, it is then necessary to refresh quickly some of the built-in secure by design features embedded in our SIPROTEC 5 platform. Because when we talk about cybersecurity strength, we must think about SIPROTEC 5. Now, let's see on this. So we have the future readiness, just mentioned. It is a platform that is ready for PKI, so public key infrastructure, with a built-in crypto chip. Also, that modularity of the platform, both in hardware and software, gives you the flexibility you require. The second, I would say the operational security, digitally signed software and firmware. Also with the Siemens product cert, it is possible to handle the vulnerabilities along the life cycle of your installed products. The third one is the compliance with the BDEW white paper. You can fulfill the recommendation for secure and reliable control and communication systems. Next, I would like to talk about the role-based access control feature, so you can centrally manage users and assign roles for authorization based on IEC 62351. Security monitoring, with this platform, you can centralize event login and can monitor the install base, which is very, very, very convenient nowadays. And also the certificate management, made easy by using with the SICAM Grid Pass. Now you can manage digital certificates automatically to enable effective and efficient management of security controls. And all that can be, rounded with the TLS encryption. The platform supports the TLS encryption by using certificates based on the IEC 62351 for IEC protocols. Now that we talk about those aspects, I would like also to talk a little bit about active security patch support and product lifecycle. I would like to give you an overview in the relation of those milestones that we have in product lifecycle and the availability of components and security patch support. Let's say that you have, at your facility, some of the first generation of the digital relays, as we remember from the mid-'80s. The end of general availability of those devices come with what is called the phase-out announcement. Keep that in mind, phase-out announcement. And that means that a product or component still can be ordered, normally for 2 additional years, but only for extensions or replacement in running projects. For new projects, we always recommend to use the newest technological successors. And we're making that easy for you, as we have available an online application, which is the Easy Relay Retrofit Selector, to support you in just doing that. Peter will show that later. After the typical 2 years extended availability comes the product cancellation milestone. After this day, you can no longer order the components, and the software update support, including the active security patch support, also comes to an end. Continuing with the example, let's say that if you have one of those earlier SIPROTEC 3 devices, which product cancellation was on the 30th of June 2007, it is advisable for you to migrate to the newest technological successors. Repair and or spare part service for defective hardware component is granted for 10 years after the phase-out announcement. A certain number of components are kept available in stock for the spare part services. Once this stock is empty, only repair of the hardware is possible. Continuing with the use case I have just mentioned, the SIPROTEC 3 devices, now Dieter will describe into more detail how to target your technological successor, which steps you should follow in order to migrate from a SIPROTEC 3 device to a SIPROTEC 5 device, and which software tools are necessary to facilitate these type of jobs. Then, here, Dieter, welcome back.
Hello, Luis. Thank you for your presentation. Now, I would like to introduce you how to migrate a SIPROTEC 3 device, in our case a 7SG602, to a modern SIPROTEC 5 compact one, 7SX800. Before we start, some explanation. Dixie Excel plugin is a support tool which enables device settings in a convenient manner. The data format TX is used for data transfer for import and export between Dixie and Excel. With the support of the retrofit device selector, we selected the new SIPROTEC 5 device. Then, with Dixie 4, we print the 7SG602 device information. We analyze the device characteristics. Based on the result, we configure the new 7SX800. In Excel Dixie plugin, we import the 7SX800 TX file. We transfer the setting data from 7SG602 PDF file into the Excel Dixie plugin. After finishing, we export the TX file back to Dixie 5 project, and we complete the 7SX800 device configuration with Dixie 5. After the device test, we are ready for commissioning. Now, we are showing you the demonstration of the Easy Relay Retrofit Selector. The Easy Retrofit Device Selector helps you to find the suitable replacement device. With the link to the device configurator, you can select the device version which fits your requirements. So, at first, you select the company Siemens, then you acknowledge the disclaimer. You select then the 7SG602, and then immediately you get the recommended device. In this case, a SIPROTEC 5 Compact 7SX800 with all his main features. Now, we know how to select a suitable device. After the device has been delivered, the device replacement can start. As next, we will show you the hardware exchange demo.
SIPROTEC 7SX800. How to perform the retrofit modification. We will show you the steps that lead to a successful retrofit modification. But before you shut down your system, the plan revision is the focus. Now that the circuit breaker is open, take a readout of the protected data from the old unit. Now bring the circuit breaker into test position. In compliance with the 5 safety rules, take the entire switchgear field out of operation and short circuit the current transformer terminals. Label the disconnected wires according to the revised circuit diagrams. Then remove the old protection device from the switchgear compartment door. The new SIPROTEC 5 compact device with its 1/6 housing is directly compatible with older Siemens protection devices. No complex mechanical adaptation work is required. You can exchange the devices one-to-one. When rewiring, please pay attention to the length of the wire end ferrules. To ensure a proper connection, you need wire end ferrules with a length of 12 millimeters. After the conversion has been completed, open the short-circuited current transformer circuits again and the mechanical protection device replacement is complete. Before electrical commissioning, perform a wiring and signal check, then the circuits can be reconnected. The SIPROTEC 7SX800 starts up independently. To carry out device parameterization with the Dixie 5 engineering software, connect the 7SX800 protection device to the PC and load the configured files into the device. The circuit breaker, which is in the test position, is switched on by pressing the key. To complete and test the protection shutdown, perform a trip of the circuit breaker using the Dixie 5 software. Commissioning is now complete. Now disconnect your PC from the protection device. Crank the circuit breaker from the test position to the operating position. The switchgear with the new SIPROTEC 7SX800 is now ready for operation in the plant. In the trailer, SIPROTEC 7SX800 Migrating Protection Device Settings, learn the simplest methods of migrating device settings from legacy devices to the new SIPROTEC 7SX800 Universal Protection Device. For more information about retrofit, watch our webinar. SIPROTEC 5 Compact, a universal device for your retrofit applications.
As you have seen, the hardware exchange is not difficult, but the replacement does not end with the device replacement alone. The device still needs to be configured with Dixie 5. We will show you how to do this in the next video. To save valuable time, the devices can be configured independently of the device replacement.
SIPROTEC 7SX800 Migration of Protection Device Settings. The SIPROTEC 7SJ602 protection device is connected to the PC. Via the Dixie 4 parameterization software, the configuration files are read into the PC with plug and play, and a PDF file is generated for further processing. This contains information about the hardware, scope of function, settings, and marshalling. How do we proceed now? In the first step, the functions of the old device, here a 7SJ602, are recorded. These serve as the basis for the configuration of the new SIPROTEC 7SX800. With Dixie 5 you can adapt an application template to the required functions of the old device. Missing functions are supplemented via the Dixie 5 device function library. In our example, the 7SJ602 functions are stored in the generated PDF file in blocks 7800 and 1300. In detail, these are overcurrent time protection with 2 independent stages and 1 dependent time stage, unbalanced load protection, thermal overload protection, instantaneous high current protection, breaker failure protection, and trip circuit supervision. In the next step, we create an adequate SIPROTEC 7SX800 in Dixie 5. For this we need the device designation from the SIPROTEC 5 Compact Universal Protection Device Configurator in the industry mall. We select the variant with 4 binary inputs and 5 binary outputs. Siemens recommends the variant with 14 binary inputs and 11 binary outputs. This allows you to easily process information, such as switch feedback, at a later time. The generated device name is now entered in the Dixie 5 configuration. Since the necessary device functions do not require any additional function points, we select the base button in the next step. You then have the option of selecting a ready-made application template. It makes sense to use the template that comes closest to your application from the legacy device. Last but not least, specify the preferred communication for the 7SX800. In the newly generated protection device, the appropriate names, for example field and device names, are now entered and the range of functions is checked. To do this, let's take another look at the required functions. The functions not included in the application version are inserted into the device by the global Dixie 5 library using drag and drop. In this case, it's the features. I2 counter system protection as an alternative, the function unbalanced load protection from the device 7SJ602, instantaneous high current protection, thermal overload protection, switching fault protection and circuit monitoring with 2 binary inputs. The Dixie 5 Excel plugin is an image of the Dixie 5 parameters in Excel format. It comes with Dixie 5. This allows the parameters to be entered clearly and conveniently. The TX format serves as data exchange between Dixie 5 and Dixie Excel plugin. By keeping the functionality of the 7SX800 almost the same as the 7SJ602 to be replaced, the data exchange procedure is minimized. with the exception of the converter data in the group power system. Of the rated values in the group UI3 phase 1, under the tab General and reference 4% values in the group Circuit Breaker 1, under the tab General, all parameters of the DIGC Excel plugin are editable. After entering these values, the TX file belonging to the 7SX800 can be exported. Please note that in the export window, under Export Contents, select Export Setting Values Secondary. You can import the TX file created by DIGC5 by selecting DIGC5 in the menu in Excel and pressing the Import button. Save your Excel file and check if all parameters of the required functions are available. In the yellow column L of DIGC Excel plugin, enter the parameters. Settings takeover of the 7SJ602 parameter setting group A. Parameter 1101 rated system frequency you will find preconfigured here. Parameter 1105 primary rated current you will find preconfigured here. Parameter 1106 secondary rated current you will find preconfigured here. The other parameters are to be changed similarly. For the correct parameter input, a detailed expert knowledge of functions and algorithms of old and new equipment is required. Functions and setting instructions can be found in the respective device-related manuals. Further support is available via our hotline or from a Siemens contact person responsible for you. After completing the parameter input, save the data and perform a TX export. They now import the TX data from their new device into their DIGC5 project. Then assign the binary inputs, the relay outputs, and the LEDs with the DIGC5 marshalling matrix. Finally, load configuration from the DIGC5 project into the new 7SX800. You can now start with the testing and commissioning work. Test support is provided by our new software SIPROTEC tools and SIPROTEC Digital Twin.
With this information and the appropriate tools such as DIGC4, DIGC5, DIGC Excel plugin, SIPROTEC Digital Twin, nothing stands in the way of a successful device replacement. Now, we will summarize the migration concept. In this slide, we see the front panel of the low voltage compartment with the legacy device 7SJ602 before device exchange and after the device exchange. The new device 7SX800 is equipped with many more additional functions than the 7SJ602. Therefore, Siemens recommends to order the 7SX800 device variant with the I/O expansion module with 14 binary inputs and 10 relay outputs. This means that the user has enough inputs available to read the on-off status from the switching devices and other information. This would be in an outgoing feeder, the feedback from the circuit breaker, the switching truck, and the line earthing switch. This each require 2 binary inputs. Therefore, 8 more binary inputs are available for additional messages. For example, truck is in test position, motor spring, tensionet, or other information. In the control direction, the circuit breaker can be switched on and off, and other switching devices with the precondition that they are motor driven. By connecting the 7SX800 to a voltage transformer, you can display calculated measured values in addition to direct measured values like current and voltage, for example, aberrant, reactive, and active power, frequency, and so on. Limit violation of information of measurement values can be generated by using the CFC, the Integrated Continuous Function Chart. With the CFC, it is also possible to create logic for interlockings, time delay function, and others. and also basic power quality functions are available. With the connection of the process to the process level to the device, you can do without the existing control buttons, local remote switch, signaling panel, and so on. The new 7SX800 can be take all these functions. The device provides an extra control button for circuit breaker control and 8 programmable function buttons for example remote or local control. All important information can be shown on the device display or via programmable LEDs. The multifunction device 7SX800 is ready for Ethernet connection. An Ethernet connection has several advantages compared with a serial connection. In addition to the classical data transmission in the measured and control direction to a high-level control center, additional service can run parallel via Ethernet. That can be goose communication for fast transfer of information to other devices, for example, information for station-level interlogging or reverse blocking signals for simple busbar protection. As mentioned before, because of the OT development, our platform are now equipped with cybersecurity elements to avoid threats in your OT deployment. Access restriction by set interfaces port to no access, read only, read and write. There is secure communication with TLS, authentication and encryption. Signed firmware validates the source of integrity of the firmware. And role-based access control for authorization. And change logging, setting history log for syslog supervision. And for your protection retrofits, we have also available a migration tool, which will be presented in more detail in our next webinar, migrating SIPROTEC 4 to SIPROTEC 5. Now, I would like Luis to join me once again.
Thank you, Dieter. And here I'm bringing my PC. Thank you for that. This is a live event, and I would like to talk to our Spanish speakers. Si usted está mirando este webinar, siéntase seguro que puede hacer sus consultas también en español. Hemos recibido algunas ya en la cajita de preguntas y con mucho gusto, ya sea directamente ahora en vivo o cuando le enviemos las respuestas a sus preguntas a través del correo electrónico, usted la tendrá disponible. Pero no sé, pueden hacerla en español y con mucho gusto vamos a contestarla. So that said, I would say, Dieter, that it has been a great presentation and with valuable advice when performing a SIPROTEC platform migration. I think that this specific example for migrating a SIPROTEC 3 to a SIPROTEC 5 may be an eye-opener for a lot of those SIPROTEC users, customers, and partners worldwide. I would like then to have, let me see here, summarizing, a couple of takeaways. You see, we are making retrofitting and migration of your platforms easy, starting from the easy retrofit device selector to allow you to easily identify your legacy devices in that drop-down list, or you can type it in, and then you will receive our recommendations. With that, just to say also that, we are doing that in a way that if the cutout of the device or based on the dimensions, you can do a one-to-one replacement, and with that, you can reduce a lot of costs. And also all these tools and programs that we have available are to enable you to do that easily. With that, remember, you are minimizing the unplanned downtime. Unfortunately, electronic, and electric-based equipment follows what we call the bathtub curve. So there's a moment where certain components will start failing. And this is, whenever you have already something of 15, 20 years old, contact us, and we can help you, in migrating those systems. And you don't have to do it, from zero to hero and go immediately from something that was developed in the 80s to a cloud connectivity, or, you don't have to go that way. We help you to do that step by step. You can start with a simpler replacement, same functionality, and then we will help you to start integrating additional functions, additional elements that will make your system more smart. And all of this, remember, rounded with all these built-in by design cybersecurity features on our devices and platforms. So that said, remember, our experienced experts are ready to assist you in preventing undesirable downtimes in an effective manner and with rapid response 24/7. We can support you in developing a high available and holistic solution to meet today's and future requirements. Our devices include all the relevant cybersecurity features and aspects you need in a highly secure and flexible system. And, Siemens is your long-term partner. We are here to support you along the life cycle of your installations at all time. So get in contact with us. And that said, I would like to start now the Q&A session. So I've seen, as I said, some questions and comments in Spanish and also in English. So we will be answering both of that. For the Q&A session, I would like to invite also Francois Simon to join us remotely. So let me check here for some of the questions. I would like to start perhaps mentioning, all the recordings. Yes, all webinars are, recorded and they will be available. This presentation is already uploaded. There's a set of documents that you can download, and there's also you already answered most probably a poll. So if you need a specific support for a specific application, get in contact with us, and we will guide you to give you your, closer contact partner, an expert, so they can evaluate and support you on that. There's here a statement, Dieter, I think that you can take this one. SIPROTEC relays don't support modbus serial. Do you have anything to say about it?
Please repeat again.
Yeah, the SIPROTEC 5 relays don't support modbus serial.
Yes, this is now the situation. That is right.
Okay.
But we have planned for the future that the modbus serial will be implemented soon.
Okay. I mean, I think that, based on that transition that is happening and the focus on Ethernet, just to complement that you said, perhaps to elaborate a little bit more for the people who are looking at the webinar, we've been focusing on those protocols that we see that the market is demanding, and which is why, IEC 61150, which is, let's say, the main driver, and all those Ethernet-based protocols, DMPI, Modbus TCP, etc., are the first one that we integrate. Afterwards, then we will, integrate additional serial protocols to allow you to continue in, let's say, for an industrial applications, for those who are using Modbus in industrial applications, the Modbus RTU is commonly used. And if you have any specific application, get in contact with us. We have, several ways on how to address different protocol integration with our gateways. So, that's just to complement that statement there. So another one is, let me go here. That goes in the same. I think I already said something like that. Like the kind of protocols that are integrated. But what is the actual firmware version of the relay that we just showed, the 7XX800?
Yes, the firmware version, the actual firmware version is 9.3, and this is coupled with the SIPROTEC 5 family.
Okay.
And if the SIPROTEC 5 family have a new version, then also the SIPROTEC 5 compact family, the 7SX800, will also have the next firmware version and the others. The same.
Okay, perfect. So there you go. That's the latest firmware version. I see here one in Spanish. It says, I'm going to read it in Spanish and then translate it. Es, aquí en Veracruz tenemos varios SIPROTEC 3 y 4. ¿Qué costo tiene cambiar a SIPROTEC 5? So here in Veracruz, we have several SIPROTEC 3 and 4s. What is the cost to, change or replace to SIPROTEC 5? What I will say there in Spanish, in English first is, it all depends. It all depends on your application. It all depends on what exactly you are protecting, whether it is a motor, whether it is a line differential, it is, a distance, transformer protection. So it all depends on the application. So what we say is get in contact with us. If you have requirements that have changed, we will be gladly to understand how your network has changed. And we can propose you also to use some of the latest algorithm available to address those specific challenges that you might be facing today. So, en español, para esta pregunta, todo va a depender de la aplicación, ¿claro? Entonces, el costo depende mucho de la aplicación. Si es, por ejemplo, en la industria o en la infraestructura, estamos hablando de una línea de media tensión o de un motor de media tensión, es muy diferente a que si fuera una línea de 400 kilovoltios y tenemos, por ejemplo, una protección diferencial de línea o distancia o, digamos, una protección de generador. Entonces, ahí lo que les recomendaríamos es que nos contacten si tienen alguna pregunta, consulta. Nosotros podemos, de hecho, o podemos nosotros ponernos en contacto con usted si está interesado para entender su aplicación específica. Puede ser que con el tiempo muchas cosas hayan cambiado en su red o en su sistema y que existan ya hoy soluciones que puedan facilitar la manera o optimizar la manera como usted está haciendo su esquema de protección y de automatización. Así que eso se lo decimos ahí como también, ¿no? Como respuesta. So let's continue then here to see some of the comments. So if I'm not mistaken, let me see. If I'm not mistaken, as soon as you use VT connections, you need function points. Although you order a 7SX800 with VT inputs, it does not have to work without function points? Dieter?
Yeah, that's right.
Mm-hmm.
But we would have to have a low-cost device, yeah, and not everyone will use the VT function.
Yeah.
But it is already integrated. The VT inputs is integrated.
Yep.
And if the customer wants to have the VT function, for example, measurements or voltage functionality, then he has to pay as for the other. This is our price system. That is normal.
Yeah, and that is, and that is fair. I mean, if you think about the application itself, I mean, why to pay for, VT's inputs if you're not going to use it? If you're using these devices for a medium voltage application where you only will use, let's say, overcurrent protections, if you want differential or if you want a, under voltage or over voltage or frequencies related, then you can integrate those VT measurements. So as Dieter said, is fair, and it's a good way to start configuring the device with the flexibility. When we talk about flexibility, this is exactly what we mean, with the flexibility that you need to integrate the elements that you need in your schemes. So let's continue, and let me see if I recall, let me see, because I saw here one, this is more in a statement, and I would like to make a comment on it. So, sir, substation monitoring system on SCADA, software Oracle database.net, JDBC, ODBC, connectivity, hardware, cloud computing, Ethernet configuration. So here what I would say is the following. So, and this is exactly what I was referring at the beginning to give the context. So cloud computing came to stay, right? And we see that trend on virtualization. So if we talk about substation automation, and we're talking about protection and substation automation, you can enable your networks using the grid edge, and then you can, pull the data up to the cloud and utilize, platforms that we have available, like the OT Companion, that can publish automatically, the let's say your installed base, and you can automatically also follow those, let's say, server related elements or vulnerabilities. This is today possible. You can use the SIPROTEC dashboard also to get additional information of the installed base. You can use the and the logs and all that. So there's a lot available happening on that, the digital twin and so on and so forth. Now, if we are talking about SCADA system, and here the Oracle part, and we're talking about Spectrum Power 5 or Spectrum Power 7, what I will say here is, this webinar is for substation automation. However, I can imagine that our grid software colleagues do have also webinars that relates to Spectrum Power 5 and 7, and how to do the patch management, taking into consideration all those softwares that you integrate in a solution, compatibility of the different elements, because those are actually the solutions that are very complex. I also know that, for example, for meter data management, Energy IP already sits on the cloud, and there's solutions available that are leveraging on cloud computing. And if you have, I would say that you remember that at the beginning I said www.siemens.com. You can go to search, and you can put grid software or the specific SCADA information that you need, and you most probably will hit the answer that you're looking for. And if not, let us know, and we will put you in contact with actually the people who can support you on those concepts that are nowadays in implementation. Let me see if I see other questions here. Oh, I see that we don't have much more time, but we check. Okay, thank you for the presentation. Do we have to check CT sizing requirements before retrofitting from SIPROTEC 3 to SIPROTEC 5? That's a question to you.
So CCT requirements, it's the same. We have no difference. We have no problems with this.
Okay.
Because the line to the CT is also short. And we must not implement in the CT calculation. And therefore, if the CD with the 7SG602 is running, then we have the CD. We have the same input values. The impedance values are the same.
Okay, perfect. So, well, there your answer. Well, I would like to, just comment something from earlier session today. That there were a question about, hey, can I, for example, this is, we place here an example, SIPROTEC 3, the 7SJ602 to the 7SX800 from our SIPROTEC 5. And the question was, can I use the 7SJ80, which is a SIPROTEC 4 device? Of course you can. This is part of our portfolio, and you can use it as part of your retrofit. However, our recommendation always is to target the latest technology, which makes sense because in the context of the life cycle of any platform, you need to take that into consideration when you want to work on a future-proof technology. So remember this, our recommendation always is to target on the latest technology. So that said, I think that we're gonna call it now. Let's call it for the moment. So thank you all for all that questions, and thank you Dieter and Francois who joined remotely. Actually, we didn't have any cyber related questions, which I'm sad. Why? Why we didn't have those questions? However,
maybe all is clear. And if not, ask us.
Yes. What I would say to the people who join, we have the answers. Call us, contact us. So for the questions not answered live, you will receive the answer afterwards. For those also in Spanish, you will receive the answer in Spanish. And remember, because I saw also the comments many times, you will have access to the recording. So as soon as this session is stopped, it's available on demand. So we also appreciate you to give us feedback. And that said, hey, this is what we have for today's session about how to keep your substation secure by migrating or retrofitting your protection relays. Thank you very much for having us. See you soon and take care. Adios.
Bye-bye.
Au revoir.